we are going to validate the requirements here. Design and implementation. Whenever a software is going to get designed, a proper structure is going to be maintained for that with the proper specification. That itself is going to get executable in the form of the programs. So once the design is going to be there, specification is going to be there, then the proper structured way that you will be going to translate that information, whatever it is there in the design, into the executable form by using the programs. You will be going to write it. These activities are going to be closely related to the interleaved operations. It's nothing but a second model, that is incremental model. This will work properly. Okay. Here the design, how the design is going to take place, and all these things that we can able to study here. You see that design inputs is there, design activities are there, design output is there. Input, activities, output. Input, process, output. I am going to say in that way. Now here you see that in the design inputs you will be going to have platform information is there, requirement specification is there, data description is there. All are inputs only here. Which platform that it should run, what are the requirements of that, what is the data that it should take. These things are going to be the input for this activity. There is a design activities. Here we will be going to have architectural design. Any program project that it should have the architecture, how that work properly, that application is going to work, that architecture design they have to prepare. Once the architecture design is there, interface of design, models are going to get interfaced with the designs. Then components for that interfaces, components are required, those components are going to be designed. All these things are interrelated to the database design. So all these things are required for application. Then the output of that is system architecture is there, database specification is there, interface specification is there, component specification is there. It means to say that architecture is going to be present, one architecture is there, complete data. So from the top to bottom, all the information that is going to present in the system architecture. Database is again, it is a separate wing, it is getting integrated with the application. There is system architecture. Then interface applications, how this interface system architecture is designed, how that interfaces are going to be present in that. Those specifications are going to be present as the output. And component specifications, individual components, how many components that is being used for this application, those specifications are going to be the outputs for this. The four components, that's what has been discussed in the previous phase, that is architecture design, database design, interface design, and component selection, and design it is going to be. So here total models are going to be one thing. Okay, how the data is being or relations are being distributed, that is going to be shown in the architecture design. Database, different types of databases, architectures of that, how it is responding for the databases, those things are going to be discussed in this. Then interfaces of the system, components are going to be clubbed and interfaced with the things, how it is defined, those things are going to be discussed in the interface design. Then we have component selection and design. First you should use that, you should see that whether that particular component is going to be reusable or not, and if it is not available, okay, so you have to design it for that particular application. Okay. Finally, the implementation of the program. Okay, so all the components are going to be there, interfaces are there, everything that you have to available, databases are going to be there, all these things are going to be available through the programming concept. All these things are going to be in the standard fashion, standard processes, it has to be integrated. That is nothing but implemented. Finally, at the end, you have to debug that particular activity for the faults or corrections in those that particular application. We'll be going to use there is one model is there, that's called as VV model. Okay, there is verification and validation model. It is integrated with the system components to its specification. It is nothing but a SRS that we want to use it. Based on the SRS, the verification and validation is going to take place for the system. Okay. It is going to be present with the reviews process as well as system testing. There is a checklist to be given. Based on the checklist, the reviews is going to take place and testing is going to be done based on the reviews. Then system testing, it involves the test cases for what and all the you have been tested that particular application. Those things are going to be specified and it should be written in such a way that whether the test is being passed or failed. If there is a severity of the failure is going to be there, that should be informed to the designer or developer, and he is going to check again with the specification. If according to the specification, if it is going to be correct, then it is going to be accepted. If it is not, so then it has to be rectified. It is V&V model is always it is good for testing. Okay. There are 3 stages are there in the testing: component testing, system testing, and acceptance testing. It is component level that if you want to test individually, independently, the component is whether it is working or not. For example, calculator is a component. I am going to test all the functionalities of calculator, then finally I am going to say that is working fine. Then component test is done. System testing as a whole, if it is getting integrated, then that time how that is going to react, whether it works properly or not, that also it is going to test. Then customer testing, when it is being given to the customer, that time, okay, whether it is going to be properly working or not. So he is going to do so many other ways that he is going to operate that particular software. Okay, then at that time whether it works properly or not, those things are going to be tested. There is nothing but acceptance testing. Okay. In plan driven process, this V model, because why it is called as V model is, see that diagram that it depicts like the V model. Because of that it is called as verification and validation model in every stages. Plan driven software process, how this testing phases are going to be there. So it has been shown in this. So here in the plan driven this thing, first is a requirement specification, again system specification, design, then detailed design are going to be there. Then once the requirement specification is going to be there, acceptance test plan is being accepted. First, based on the requirements, you'll be going to accept that. Then system specification is going to be there. So when you'll be going to design, so this acceptance test must be coordinated with the system specification. Next is system integration. When it is getting integrated, the specifications, the models have been designed. You see that system design and specifications both are clubbed with system integration test plan. Okay, so once the design and specifications are going to be there, it is components have been developed, system is developed, integration test is being done. So if it passes, then system integration test is being passed here, and system design and detailed design. There are so many subsystems are going to be there. Subsystem integration is going to be there. Those test plans you have to execute. If that is going to work properly, then subsystem integration test is being passed. Okay. Then finally the model, okay, design detail, model and unit testing. Individual things are going to get tested. Individual models are going to be tested. Coding, okay, individual programs have been tested, and we say that the time the subsystem is already tested. Integration, this whole system is tested. When we test about the unit model, unit coding, unit code testing, okay, so each and every code is being tested, and that means in that subsystem, system integration, acceptances, everything is going to come in that. So all these things are being tested. Finally the service